Have you ever wondered how your computer knows if another device is in the same room or across the world? It's not magic, it's math. Specifically, it's the work of a hidden number called the network mask. Today, we're demystifying network masking and subnetting. Let's dive in. Every device on a network has an IP address. Think of it as a street address, but for the internet. An IPv4 address consists of 32 bits, divided into 4 segments called octets. While we see decimal numbers, computers only see ones and zeros. This binary view is the key to understanding masks. A subnet mask is a 32-bit number that accompanies an IP address, acting as a filter. It tells the computer which part of the address is the network identity and which part belongs to the host. A subnet mask is a 32-bit number that accompanies an IP address, acting as a filter. The ones identify the network, while the zeros identify the individual devices or hosts. A common mask, like 255.255.255.0, means the first 24 bits are dedicated to the network. This distinction allows routers to direct traffic to the right neighborhood before finding the exact house. Historically, IP addresses were assigned in rigid classes, A, B, and C. Class A was for massive organizations supporting millions of hosts. Class B and C offered smaller blocks, but this system was incredibly wasteful. In 1993, classless interdomain routing, or CIDR, changed everything. CIDR introduced slash notation, like /24, indicating how many bits are ones in the mask. This gave administrators the flexibility to create networks of almost any size. But why go through the trouble of dividing networks at all? First, efficiency. Subnetting prevents the waste of precious IP addresses. Second, security. You can isolate sensitive departments from general guest Wi-Fi. And finally, performance. It limits broadcast traffic, preventing network congestion. To master subnetting, you need 3 essential formulas. First, to find the number of subnets, use 2 to the power of n, where n is bits borrowed. To find total IPs per subnet, use 2 to the power of h, where h is host bits. Finally, usable hosts is 2 to the power of h minus 2. We subtract 2 because the first and last addresses in every subnet are reserved. The first is the network address, identifying the subnet itself. The last is the broadcast address, used to shout to every device in that group. Let's look at a practical example. A /26 subnet. A /26 mask has 26 ones in binary, ending with 2 ones in the last octet. In decimal, this mask is 255.255.255.192. By borrowing 2 bits from a standard /24, we create 4 subnets. Each subnet has 6 host bits remaining, giving us 64 total addresses. Subtracting the reserved addresses leaves 62 usable hosts per subnet. A pro tip is the magic number trick. Subtract the interesting octet from 256. 256 minus 192 is 64. This tells us our subnets start at 0 and increment by 64. The first range is 0 to 63, the second is 64 to 127, and so on. Today, network administrators use tools to handle these complex calculations. A subnet calculator is a vital tool for preventing IP overlaps in modern cloud environments. And with IPv6, address exhaustion is no longer an issue, though the logic remains the same. Advanced networking also uses VLSM, or variable length subnet masking, to maximize efficiency. Understanding network masking is still critical for troubleshooting routing loops. This allows a large office to have one big subnet for staff and tiny subnets for direct router links. Let's recap what we've learned today. Careful planning ensures that your network can grow without needing a complete IP overhaul. The subnet mask is a binary filter that divides the network from the host. A solid grasp of masks is your best defense against the dreaded IP address conflict. CIDR and /notation provide the flexibility modern networks require. Subnetting improves security, performance, and address efficiency. Always remember the -2 rule for network and broadcast addresses. Mastering this math is the first step toward becoming a networking professional. If you found this helpful, subscribe for more deep dives into the world of IT. Check the video description for the subnet calculator tool mentioned in this video.